Okay, let's talk about e to the x in general and then the derivative of this. And again, this is simply review from last semester, earlier last semester. So if you would, give me your coordinate plane. And e to the x is exponential, meaning we have a horizontal asymptote at y equals 0. And it goes through a critical point, not this pen. There you go. 0, 1. So it's going to go along the asymptote and ever so slightly increase. And once it hits 0, 1, it'll go up quite abruptly. So one thing we can conclude from e to the x. Does e to the x ever reach 0 on y equals 0? Does it ever reach negative? No. So the bottom line is e to the x is always positive. So because it's always positive, the derivative will also be positive. So here's the bottom line. F of x given e to the x, f prime of x is also e to the x, f double prime is also e to the x no matter what. So that's a nice thing about e to the x. So then I want to kind of remind you of card number 3, which is basically this box. If you don't have this card, that's okay, just look at the board. The colors are better though, right? Yeah? All right. So I'm going to remind you of last semester. To find the derivative of e to the u, it's basically e to that times the exponential that is derived. All right? It is itself, and you derive the exponential. Or the exponent, I mean. Oh, it's still there. All right. So let's go ahead and apply that on number 7. Let's see if I can zoom in. Oh, yeah. Can you guys all see that okay? All right. Let's start by circling our power. So my power is this guy right here. So if I find the derivative, it's going to give me the following. Y prime is equal to. You copy the original as it is. And at the end, all you need to do is find the derivative of 3x minus 5. What is the derivative of that? 3. Now, if this were to have been a multiple choice question, the way it's going to be formatted is with the coefficient in front of the e, although they mean the exact same thing. Everyone good with that? All right? So now let's go on to number 8. On number 8, looking at the power, what do I not like about the format of the power? It's got x on the bottom and it's fraction. So let's go ahead and make it non-fraction. So we have e to the power of negative 7, x to the negative 2 power. Now circle your power. And let's derive. So y prime is equal to, copy the original as it is. And when I derive the power that I've circled, what would that give me?
14x and negative
14. Ooh, we're deriving. One less power. We're not integrating. Negative 3. I know our brain is like, what are you doing to me? If this were to be a multiple choice question, the format you will see is the following. 14, e to the power of negative 7 over x squared all over x cubed. It's basically controlling the powers to make it a positive exponent. Okay, let's move on to number, what's the next one? 9? All right, I'm liking it. On number 9, what do we remember about relative extrema?
It's like changing from positive.
Changing direction or changing positive to negative. In this case, when your slope is equal to 0. I don't know why my line is slanted. It's supposed to be horizontal. All right, so that's when relative extrema happens when f prime, which is our slope, is equal to 0. And that's going to give us our critical numbers to test from. So I'm going to rewrite this guy as our product rule with parentheses, because to me that's friendlier. If you don't need it, that's okay. So f prime. So let's kind of recall product rule. Do we derive first or we copy the first term?
Oh, wait, you're right.
We derive. Derivative of x is 1, and you copy the next one as it is. What operation separated product rule?
Addition.
Addition. And then we keep the first one. And what is derivative of e to the x? E to the x. And what is the derivative of that power?
E to the x.
1. Derivative of the power is 1. And I don't need the 1, so I'm going to leave that alone. Let's see if I can factor out something between these two. What is common between these two? E to the x. So let's take out e to the x. And I'm going to put that in parentheses because I like parentheses. And I have remaining 1 plus x. So I need to kind of ask myself, when are these two individually equal to 0? So e to the x is equal to 0. 1 plus x is equal to 0. Can e to the x ever reach 0 or negative?
No.
So we know that's not even a thing. So it's not a critical point. So on our next piece, my critical point has to be negative 1, as in critical number. And back in unit 2 or whenever, we did a number graph with infinity and negative infinity. And since we only have our one critical point, put that in the middle. And we're trying to figure out what is the behavior of the function when testing f prime. When you are testing, please test it into your factored form. And by that I mean into this one and this one. What number is clever for us to test on the right side of negative 1? 0. Now if you want to test 10, that's okay. What number is clever to test on the left side of negative 1? Negative 2. So since I'm testing into my factor form, e to the x is always positive. But when I plug in negative 2 into my second factor, that's going to give me a negative. Is that right? Positive times a negative is a negative. So that means the graph is physically going down because my slope is negative. The next one, no matter what I plug in, e to the x is positive. What do I get when I plug in 0 into my second factor? Positive. So we know our slope is positive, meaning physically the graph is going up. So is that a relative minimum or a maximum? Minimum. So let's summarize this. There is a relative minimum at x equals negative 1, and that is specifically because f prime is changing. Yeah, you can't just say changing sign because it'll change sign at maximum as well. Changing from negative to positive. Right, Xavier? Looks like your phone's in the corner, kind of. Looks like I'm not saying anything. All right, for number 10, we're gonna use a calculator. So if you have your own, get them out. If you have a class set that I've assigned for you, go get it. If I give you a calculator form on any part of the test, you cannot miss a question like this. Ooh, there we go. Cody, let's read. We're reading.
From 1970 to 1990, the number of medical doctors in the United States can be modeled by y equals 348,000 e to the 0.0336616, where t equals 0 represents 1970. At what rate was the number of entities changing in 1980?
So when we were integrating, we did math 9. Y'all remember what math we went to for derivative? 7, it is 8. Pretty close to 7, math 8. And here's what we are going to type in. The function, or once we get math 8, it's going to give you the skeleton model of the derivative. It's always with respect to the x. The parentheses is where the function is going to go into. So 3, 4, 8, 3 zeros. And my e is second. Natural log is going to give me the e. And if you can't find it, tap on your neighbor, please. And the very small decimal power. And my t is replaced with the x. Let's talk about what the x value is. If t equals 0 represents the starting of 1970, what is our t value at 1988? How many?
0.
Oh goodness, 1970 is 0. So 1988 must be 18. So here's my calculator. D of x with the function, and at the end, put in x equals 18. And that's going to tell us the value of our doctors. How many do we have? 21,475.7. Let's make it to 3 decimal places to make it a normal for the AP test. And that's MDs per year.
Ms. Broadway, I don't understand how you got the
18 came from, if 1970 is 0, and I keep collecting t equals 1, 2, 3, it'll reach
So
at
18
t equals
years
18.
till-
Yes. All right. Let's do some reminder on implicit differentiation. Y'all ready? Number 11. Hudson, let's read. 11.
11. Use implicit differentiation to find dy over dx.
Of?
So, x e to the y minus 10x plus 3y equals 0.
So that means find the derivative. So derivative with respect to x. And I'm going to write the piece I see a product rule and expand it with my parentheses. I see an x, and I see e to the y. So anywhere I'm deriving an x, I'm good as it is. Anywhere I'm deriving a y, y'all remember doing dy over dx? Okay? A good reminder. So the first one is a product rule. Derivative of the x is 1. You keep the second piece. Plus, you keep the first piece. And then what is derivative of e to the y? E to the y. And if I derive that power, it's still 1. But because I derived something with the y, we need dy over dx. That was the first part. Now let's go to our second part. What is a derivative of negative 10x? Negative 10. And that wasn't with the x. I don't need anything after. What is a derivative of 3y? 3 dy dx. And we know our derivative of the constant on the outside is always 0. My goal is to make dy over dx by itself, and I'm going to do that one go at this point. All right, we are going to subtract ey, and then we're going to add 10, and we're going to divide it by the coefficient in front of the dy over dx. So here we go. Minus e to the y plus 10. And then I have x e to the y plus 3. And it says make dy over dx by itself, and I did. Again, it is a good reminder. All right, the last one. Lily, go to me the last one, please.
Find an equation of the tangent line to y equals x squared e to the x minus 2x e to the x plus 2 e to the x at x equals 1.
So equation of a tangent line means I need a point and I need a slope. And our slope is determined by f prime. Derivative is a slope. Now anywhere I see a product rule, I'm going to go ahead and elaborate. So I see x squared e to the x. Do I see another product rule anywhere? Is there another multiple x? Yep. Negative 2x and e to the x. Go ahead and derive this piece with the neighbor real quick. So practice product rule. Did we get the first part? And then here's our second part. And then my third one, since e to the x derivative is just e to the x, and we have that coefficient that needs to follow along. So let's see where I have our possible zero pairs. Do I have one that's identical, positive, and negative? Yeah? Do we see 2x e to the x, negative 2x e to the x? Cross them off. There should be one more. Good. Negative 2e to the x and positive 2e to the x. So we know when I plug in the value of 1, that's going to give me, from the remaining, and I'm plugging into this guy right here, 1 squared times e to the 1. That is going to give me the e. But then that's our slope. So we got that part down. To find the point, our point, the x coordinate is 1. To find the y coordinate, all you have to do is plug it back into the original. So we have 1 times e to the x is simply 1 minus 2 times e plus 2 times e. Do I have another set of zero pairs here? So let's cross them out. So we know our y coordinate must be simply e. And when I label this, here's our x1 and y1. That is our slope. And if you recall point slope formula, it was y minus y1 is equal to what? M times x minus x1. Let's plug it in. Y minus e is equal to e times x minus 1, and that's it.